Hello, you're welcome back. All right, here we're going to be looking at a past examination question on binary operation. Okay, all right, so I hope you're ready. So let's begin. Solution. Okay, so now the very first question here is um, if m asterisk n is defined by m all over n minus n all over n, so that is the definition of the operation is m all over n, then minus n all over m. All right. So we are to evaluate minus 3 asterisk 4. Okay. So comparing now. All right. So for minus 3 asterisk 4. M represents minus 3 while n, okay, is being represented by 4. So that's going to be equal to, so we'll substitute into the formula. Okay, so minus m is minus 3, n is 4, then minus n is 4 divided by minus 3. All right, so this is going to be equal to minus 3 all over 4, right? Of course, minus times minus is plus. That's minus divided by minus is plus. That's plus 4 all over 3. So just have to simplify so we just have to simplify this fraction. Okay, so you can just do that by cross multiplying, right? 3 times 9, 3 times minus 3, that's minus 9. 4 times 4 is 16 plus 16. Then divided by 4 times 3, which of course is 12. All right, okay. Now, of course, minus 9 plus 16, that should give me 7. So that is 7 all over 12. Okay, I hope that is well understood. Very simple. Okay, so let me solve this. This question goes this way. A binary operation asterisk is defined by a asterisk b equal to ab plus a plus b for any real number a and b. If the identity element is 0, find the inverse of the two. Okay, so our solution. So we're looking for the inverse of 2. All right. Now, you know very well that um, the inverse of any binary operation, right? So the inverse of any binary operation, that is 2 times, let's say, A inverse, is supposed to give us the identity element. Okay, so if the inverse is a 2 of inverse, so what we need is to be able to find the identity element. All right. Okay, already the identity element is said to be 0. Okay, so that means 2 asterisk the inverse of 2, which of course I call it A inverse, all right, is equal to the identity element, which of course is 0. So now what you're going to do is we use this definition to evaluate. The definition, okay, is A asterisk B is equal to AB, all right, plus A plus B. So in this case, A is being represented by 2, while of course B is being represented by A inverse. So we are going to use this definition. So wherever I see A, I put 2. That's going to be 2 there. Of course, for the B, that's going to be my inverse. 2A inverse plus 2. Then, of course, plus A inverse is equal to 0. Collecting like terms, 2A inverse plus 1A inverse will give me A 3A inverse plus 2 is equal to 0. Okay, so rearranging the equation now, then you know very well that A inverse is going to be equal to, I take 2 to the other side of the equation. That's minus 2, of course, divided by 3. All right? So that is the inverse. Take note of that as we look at another question. Okay. So in this case, solution. If m asterisk n is equal to n minus bracket m plus 2 for any real number m and n, find the value of, all right, of course, this is very simple. We already know the definition. M asterisk n is equal to n bracket open n plus 2. So for us to be able to evaluate 3 asterisk minus 5, in place of m, I'm going to replace it by 3. In place of n, I'm going to replace it by minus 5. This is going to be equal to, okay, minus 5 bracket open, of course, 3 plus 2. So this is going to be equal to minus 5. Okay, open the bracket. Of course, 3 plus 2 is 5. Okay, so that's another minus 5. Minus 5 will give minus 10. As simple as that. All right, next question. So what I'm going to do, I'm going to take this question up. Okay, here we go. So, solution. So the question goes this way. A binary operation, of course, this is a symbol right here, okay, defined on the set of integers is such that m, all right, operation n, whatever that symbol is, okay, let me just call it operation n, m operation n is defined by the formula m plus n plus mn for all integers m and n. Find the inverse of minus 5. Okay, very simple, the same way we evaluate the, all right, the previous inverse, but that's what we don't have here. Okay, we still have the identity element, all right. The identity element is also given as 0, so that means minus 5 asterisk the inverse of minus 5. Let me use a raised power minus 1 to represent inverse, okay, is equal to the identity element, and the identity element is equal to 0. So anytime you want to find the inverse of any operation, all right, establish that operation with the inverse, then equate it to the identity element. Whatever the identity element is, that's going to be what you're going to equate that operation to. All right. So you now use the definition that was given to express this operation right here. Okay. So from this operation right here, you know very well that minus 5 is being represented by m, while a inverse, all right, the inverse is being represented by n. So let's use this definition to express that. So any place I see m, I'm gonna write minus 5, then plus n, that is the inverse we are looking for, then plus m, all right, still minus 5, then n, the inverse that I'm looking for. Okay, so this is gonna be minus 5 plus the inverse, open the bracket, that's gonna be minus 5 a inverse is equal to 0. Collecting like terms, plus a inverse minus 5a inverse, 1a inverse minus 5a inverse, all right? So that's going to give me minus 4a inverse equal to minus 5. So that way minus cancels minus. So you now have that a inverse is going to be equal to 5 all over 4, which of course, if we simplify that, we will have 1 whole number 1 all over 4. Okay, so I hope that is well understood. Here I have another question. Solution. All right, so here x asterisk y is actually being defined as x plus y square. So we are being asked to evaluate 2 asterisk 3 in a bracket, then asterisk 5. Okay, so you know how we're going to do that? By the principle of body mass, we are going to evaluate the bracket first. So to evaluate the bracket, you know very well that the 2 is being represented by the x, while the 3 is being represented by the y. Okay, or the s is represented by 2, y is represented by 3. So that's going to be equal to any place I see x, I put 2 from this particular expression. Then, of course, if I see y, I'm going to put 3, that is 3 squared. So this is for the bracket. Then, of course, asterisk 5. So let's evaluate the bracket. So this is going to be 2. 3 squared is 9, all right? Then 9 plus 2, that is 11. So this is going to be 11, then asterisk 5. So at this point now, 11 represent x, 5 is representing y, okay? So still putting it into this formula. Any place I see x, I'm going to write 11, then plus 5 squared. So this is going to be equal to 11 plus 5 squared, which of course is 25. 11 plus 25, that should give us 36. All right, so the answer is 36. As simple as that. Okay, so if the binary operation asterisk is defined by m asterisk n is equal to mn plus n for any real number, m and n, find the identity element. Okay, this time around, what we are looking for is the identity element. So I'm going to show you how to find identity element. All right, solution. If you want to find identity element, all you just need to do is replace the second operation by the identity element. The symbol for identity element, we use E. By the time you replace the second operation, all right, the second variable in the operation, please pardon me, the second variable, which is m, by the identity element, okay? So then you now equate it to m. So identity element is actually the element that when you actually operate it with the first element, with any element, it will still give you the same element. That is what it means. That is the definition. So if I do m asterisk e and I still have m, all right, then it simply means that what I use, that e, is actually the identity element. So let's evaluate that. So using this definition, you know very well that m, of course, is being represented by m, while the n now is represented by e. Okay, so let's go there. So this is going to be equal to m e, then plus, of course, m, then n, I will replace that n by e. It's equal to m, okay? Of course, I'm going to collect light terms together. Collecting light terms together, all right? So what I'm going to do is, okay, of course, I'm looking for e, so I'm going to um, factorize e, all right? And then I'm going to take m to the other side of the equation. So if I take e out, so of course, I'm going to put e, this is going to be 1 plus 1. Then I'm taking this m to this other side of the equation, all right? So that's going to be equal to m minus m, which of course is 0, okay? So it will cancel out. So you know that from what we have here, this is going to be 0 divided by m plus 1, which of course is still 0. So the identity element is 0. Okay, so all this time, I don't know why identity element is always 0. So the one we've actually saw previously, the identity element was actually given as 0. So maybe probably say actually a common value for identity element, right? So I hope that is well understood. That is all the question I have for you. in this video, right? Let's look at more in the next video. So see you in the next video. Thank you very much.